Welcome to ISDT's knowledge series. My name is Yogesh Kothari and I am optometrist by profession. I hold a master's degree in optometry, MBA and Masters of Art in Strategic Studies. I have around 26 years of experience in eye care sector, basically in the optics, dispensing optics, teaching, contact lenses and various other areas. We have created this series basically to make sure that people who are in the optical sector, basically opticians who are the integral part of the eye care in India, and people who are working in the eye care sector in general. So this series is intended, and this series will be looking at the basic topics like ophthalmic optics, dispensing optics, frames and various other areas which everyday life you need in everyday life. So let's start now. We will first look at when we study eye care, basically anything, like if you are an optician or optometrist or anybody who is working in the eye care, we need to know the basics. Basics in a sense like the light, the optics, how light and the materials interact, how we see, and the basic phenomena of the vision and visual perception. Again, then there are the areas which are optical, purely applied optics, like lenses and their surfaces, their aberrations and lot more things. We will start with the basics, and as we build the rapport, as we build the lectures, we will go on to the some higher topics which I hope you will like and you will appreciate. So let's start with the first lecture of this series is ophthalmic lenses and the optics. So we'll start with the optics first. Let's see what is optics now. See, now optics is basically the study about light and its properties, and we can extend that definition little bit, that its interaction with various materials and therein the properties of that light, how the light ray passes or how the light ray behaves after striking up some material or passing through some material. It can be defined as the electromagnetic energy. So everybody in like 7th, 8th standards have studied electromagnetism and the light as a form of energy. Light is defined in the two forms. One is the corpuscle, that means the packets of light, and the waveform, that means the waves of light. Now there are the different uses of light and different sources of light. Sunlight is the one basic source of the light. Then there are the artificial sources like bulb, tubes and whatsoever. So this light has certain properties. Now we look at the light as an electromagnetic spectrum. Now what you see on the board are the waves. These are the different waves, and if you look at these waves are from spread up to the very compressed form. This whole thing is called as electromagnetic spectrum. We can define that in the way of colors as well. That means different wavelengths give different color. That means property of color is because of the different wavelengths. This is what you can understand from this. So at the left hand side of the spectrum is the radio waves, which are the larger waves. As the size of the wave decreases, you have microwaves. Then you have the visible light here. In visible light, you have regions from ultraviolet light to the infrared light. And then there are X-rays, gamma rays, etc. etc. Now the light travels from its source to the, say for example, to the eye. So basically there are certain properties of the light, how it travels. One is light travels in an absolutely straight line. Unless and until there is a curvature in between or the obstruction in between, it won't change its path. Light travels as a wave, and particle nature of the light defines certain properties, optical properties of the light. So now you look at this, this is the amplitude, that means how many times it vibrates or what is the range of vibration, and you look at the troughs and downs in the wavelengths, and there are different short wavelengths, larger wavelengths and whatsoever. Now you can say the sources of light is the luminous bodies. These are the natural sources. Other sources of light, thermal sources, gas discharge, luminescence sources, non-luminescence body, etc., etc. Okay. Now, first property of the light is called refraction of light. Now, what is refraction? Please mind my handwriting, it is not very good, but please bear with me. Now, what is refraction? Refraction can be simply defined as when light passes through a transparent object. That means light passes through an object is refraction in a simple way. So now when will light pass through object? When it is transparent. So light passes through a transparent object. That means the property of light to pass through an object in bracket transparent could be defined as a refraction. For example, you have a piece of glass here. You have a source of light here. Now we have seen that light passes in a straight line. So light is passing in a absolutely straight line. You can say it passes as a wave. So this is a wave that is coming up. Now at this point of this surface, it is striking. And if this surface is transparent, this light will pass through this surface and come out from the other side of the surface as a wave. Now this phenomena is basically called as refraction. That means passing through of a light from a surface or a medium. So from a medium, when light passes through, that is called as refraction. That is one of the important properties you need to keep in mind. So here what we have seen, refraction, light passes in a straight line, light passes as a wave, it passes through a medium, we call this a medium. It could be air, it could be water, it could be glass, it could be anything through which the light can pass. So this light passes through and it goes to the same medium or the different medium after passing through. So this phenomena is called as refraction. Okay. Now the second property of the light is called as reflection. I will just rub this off. So three terms you need to keep in mind. One is the medium, one is the source of light, then light passes in a straight line and it travels as a wave. Now next property is the reflection of the light. Now what is reflection? Now again we will take some medium. Now this time the difference is this medium could be anything, the hard surface, a table, a chair, a wood or whatsoever. So now when light comes from a source, this is a source, it travels in a straight line, it travels as a wave and it hits the surface here or this medium here. Now after hitting the medium, when it get bounced back in the same medium, that means we can say this is medium 1, this is medium 2, again this is medium 1. So it come from a medium 1, hit the medium 2 or the object or whatever you call it, it gets bounced back in the same medium again. So this bouncing back is called as reflection of the light. This is again one of the most important properties. Now the most common example is this mirror. When you have a light and you throw a light on this mirror, what happens? It just gives you a reflection, right? You can see that light again. It doesn't pass through to this board. Now this is the air. I have started up the light. and it is falling on the board. That means it is passing through this air. Now I put this mirror in between and I put this light. It is not passing through, it is just reflecting back. So mirror is the most common example of the reflection or the reflective surface. So now this is about the reflection. Now as we have seen, light is a form of energy. So this energy get refracted, it get reflected. Now the third phenomena is called as absorption. It is absorption. Now what is absorption? Now I will just keep this medium again, keep the source again. We will consider this medium as medium 2 as say a iron plate. This is say iron plate. Now, and we consider this as a strong source of light, sun. This is sun. Correct? So the sun rays are falling on the iron plate. This wave is falling on the iron plate. Now as this iron plate is not transparent, it is a solid iron plate. So what is happening here is it is not refracting any light. No light is passing through this iron plate, but it is reflecting some light. If it is absolutely clean steel plate, it will reflect more light. If it is a rough surface, it will reflect less light. So now what is happening, after few minutes when we keep this into the sunlight, this started getting heated. That means temperature of this surface started going up. How and why? Why this surface temperature is going up? Now there is nothing, you have not put any fire or anything, but there is only a sunlight and there is an iron plate, but still that surface is getting heated. So what is the reason? That means only logical conclusion could be the light is getting absorbed into this, as it is an energy and it is hitting it. So this specific phenomena is called as absorption. Now let's consider the other example, other medium. Say for example, this is a water, this is a lake. Now this light is falling onto the water surface and you are sitting in a boat somewhere here. Now what is happening is you are seeing this light reflected. When you look down till certain level, you can see this light refracted. And if temperature of the environment is high, the climatic temperature is high, you will see this water is little bit warm. So what is happening here? Here three phenomena you can see in sync. One is light is falling from the source on the water surface, it is reflecting, that means reflection is happening here. So this is a reflection. It is passing through the water, as water is transparent. So it is refraction, and water is also getting warmer. That means some part of that light energy is getting absorbed into the water, and that's why it is getting heated. So this is the classic example where you can see reflection, refraction, and absorption. So absorption is what? The light energy get absorbed into the surface or into the material, and temperature of the material could change. That means that energy get absorbed into the material. Certain part get reflected, may be refracted, but certain part gets absorbed into the material. That is called as absorption. Now this light coming from the sun has some velocity, some speed. So what is the speed of light? Now from sun to the earth, here is a vacuum, here is a vacuum, and now this light passes through this vacuum or this air, you can say, maybe less scientifically, but air. So the speed of light is around 3 lakh kilometer per second. Exactly, if you want to know, it is 299 0.797 kilometers per second. So at this speed light comes to the earth. This is one of the properties you just need to know, and that's it. So now we have seen this about light. That one, now we will just summarize what we have seen. Light has a different sources. Light is a form of energy. It travels in a form of waves. Light can be considered in two dual forms. It is called as dual nature of light. That means one is corpuscular or the packet form, and one is the wave form. Now this light has, as it is wave, that means it has some frequency, and based on that frequency, light shows us different colors. Again, these colors, that means light can be described in a form of spectrum, electromagnetic spectrum, where at one end there is an infrared light, that means a larger wavelength, and at the other end there are the ultraviolet regions, which are the shorter wavelengths. In between those two there is a visible region. It's around 780 nanometer wavelength is the visible region, which is yellow light, which is sunlight, what we see. Infrared and ultraviolet we cannot see. Now next property of the light is how it behaves when it hits the surface, any object, surface, whatever. Now when it hits the surface, either it can get reflected completely, it can get refracted, or it can get, the amount of that energy can get absorbed into that surface. Now that surface means if it is a completely black body, it absorbs 100% of the energy or 99% of the energy. If it is a glass, some part will be reflected, some part will be refracted, some part will be absorbed. In water, exactly same thing will happen. Now what is the implication or what is the application of this whole understanding? The question arises, why do we need to know this? Now we'll go to the some little depth on this. Like when we see, what exactly, how we see, everyone sees through the eyes. So if there is no light, what happens? If you are being put into the room where there is no light, what happens? We won't be able to see anything in the room. That means to see, light is the most important part of seeing. If there is no light, you cannot see. So now this is the most important application. So how do we see? Now we will just touch the topic, because it is a detailed topic and it will come up in some next lecture. So the light comes from the sun, the sunlight comes, it hits on some object, that object reflects that light, that reflected light gets into our eye, through our system of the eye, that means optical system of the eye, it goes on to the retina, that is the screen, goes to the brain and we see. It's like in simple way we can describe it that way. That means what happens is, here is the sun, here is a object, this is a pyramid you can say, here is your eye. Now you just here is the eye, or you can see from wherever, that means sunlight is falling from all the sides on this area. So how do we see? So the light which is reflected from this pyramid enters into the eye, hits the retina, goes to the brain, and we see. This is the application of the study of the light, why we need to study the light. Now once we know there is reflection, there is refraction, and there is absorption. So these three properties we need to understand and we need to apply them in daily counseling, daily understanding of the light or the refraction or whatsoever. So now we will go to the next part of this thing, the application of this light. Now the optics of the lenses basically. Now our focus is on we will talk about the lenses. Now why lenses is like, this is what we need to understand, because this is what we practice in our daily lives. So now what is a lens? Let's put lens here, lens. Now we are going to look at the lens. What is lens basically? Now can you define a lens? So to define a lens, we need to understand what exactly it is. We can define the lens from its function or from its form, how it looks. So basically lens is any surface that refracts the light and focuses the light at some point. That some point could be at infinity or could be a finite point. Now let's see what is the infinity point. Suppose you have a sheet of glass, a window pane for example. This is a window pane. If you look at this pane, you will look at two straight parallel lines or two surfaces which are parallel, or single surface maybe is a parallel. It does not have any type of curve or wave or anything into it. So light from the source, this is a source, from the source light comes, light hits, and exactly in the same direction it goes. Where it stops, so wherever there is a hindrance or there is a object in between, it will stop, or if there is nothing absolutely, it will just keep going till infinity, right? So this lens or this particular object allows light to pass through and it travels in a absolutely straight line to the infinity. Now we need to use this specific phenomena in a real life application. Now as we have said, this is going to infinity. Now I put one screen here. This is a screen. This is not a mirror, but this is a screen. Now what happens? Now light, this is not a transparent screen. Now light hits here and it creates an image of the source here or image of the source here, right? So this is getting refracted and been stopped here. So you see some light there. This is some light. So this light, irrespective of the size of that image, we can call it image, is the image of this object basically. So now let's understand how we can use this. Where do we use this basically? If we stop this light, now if you look at the whole thing, it resembles the eye. You have a source of light, you have some optical element here, and you have a screen here. So when this screen catches the light, if you have something that is going towards, say for example, here is a computer going towards the computer processes and it creates the image. What we can call it, we can say the projector for example. Projector does what? If it is connected to computer, it takes that image, it focuses that onto the screen and you see it. So this may not be a very scientific example, this is just an example so that you can understand the topic clearly, you have a clarity about the lens. Now how do we apply this phenomena in real life, that means in the eye care or in the various instruments or say spectacle lenses and focusing instrument and etc. So now this is called as a plane surface, plane, because it does not have any curvature. Now again, if we go in little bit depth, this is a part of a bigger curvature. So we cut, suppose for example you have a big curvature and I cut this part, so it looks as a straight line, a plane line. So this can be called as a part of a bigger curvature. So for our purpose we will take it a plane surface. This is a plane surface. So this plane surface refracts the light and let it pass through to the infinity, because it does not, if you look at this ray and this, they are absolutely in a straight line, it is not been deviated, it has not changed its way. So now if we want to use this, what we can do? So there is an invention called the lens or the focusing lens, we can say, the lens that can focus at some finite point. So instead of having this plane surface, what I did was I curved this surface from both the sides. Now this looks familiar, right? This looks like a lens. Now when this light strikes this surface, what happens is it passes through this, we can call this, we can say this is a thick lens, the lens which has certain thickness in between. This is the surface 1, this is the surface 2 of that lens. Both the surfaces have some finite radius. That means if you just draw this back, it will create some kind of curvature this way. Or you can say in simple ways, I have two circles which are intersecting, and this part is your lens, right? So now I have, the light has passed on this, fallen on this, and now it has changed its path. Now instead of going in an absolutely straight line without changing the path, this way it has changed the path of that light. That means who has changed the path? This curvature made that path to be changed, the light to be deviated. Now this light will fall, change here somewhere, and it will go to the infinity again. But now when I put something in between here, so image of this will be created at this point somewhere. Suppose we will just draw a object here, say this is object, this is a light coming to it, passing through it this way. This is the second ray that is going through a center, again it is intersecting to this point. Here is the another ray that is coming, it is again intersecting. Where all these rays intersect, that means get focused. Basically this lens is doing what? It is focusing. You get the image of that source this way. So this is how the lens works. So this is how we use the light, or we get the application through the light in seeing, in creating the images, in focusing the objects at certain distances. Say for example stars, if you photograph a star, or if you photograph something through a zoom lens, so it is, say for example, say 5 lakh kilometers from the earth, and you are photographing it. What exactly you are doing? You are capturing that light into the lens, that lens is focusing that light onto the screen or the film or the sensor, and image has been created at the finite distance, so you can get that particular image. So this is how the lens works. This is what the lens is. Now in the next lecture, we are going to see the lens, the types of lenses, the materials of the lenses, the properties, optical properties of the lenses, and how they are applied into the eye care. So for today we will stop here, and in the next lecture we are going to look at the different properties of the lenses, types of lenses, etc. Thank you so much. We will meet in the next lecture, but don't forget to subscribe my channel ISDT India for getting new videos, new information. And if you have any questions about the topic, you can just put in the comments, or you can contact us at our academic department. You will find our contact details here. Contact us if you have any questions, if you want any topic to be incorporated. So based on the demand for that topic, we will definitely make a video for that, and will help you understand the topics. Again, give us the feedback, how you like the lectures, how was the content, do you understand the things and that, and so we can improve continuously. Thank you so much.